Welcome to qnawire.
All right, guys, we're doing problem 56 of chapter 9 of Chemistry Essential Science. So, if the valence atomic orbitals of an atom are sp hybridized, how many unhybridized p orbitals remain in the valence shell? So we can when we talk about hybridization, we can have we can have sp, we can have sp2, or we can have sp3 hybridization. So if our atom is sp hybridized, that means we have two. That means that we have two p orbitals that are non-hybridized in the valence shell. Now they want to know how many pi bonds can the atom form, and that's very simple. So when we use pi, when we form pi bonds, we're adding p orbitals into us. We're adding p orbitals. So that means that. So let me rephrase. When we are adding p orbitals, when we are making pi bonds, we have a sigma bond, we're making pi bonds. Those are what our p orbitals are used for. Those what our free p orbitals are used for. They're used to make pi bonds. So if we have two free p orbitals, two non-hybridized p orbitals, else we can form two more pi bonds. So now, imagine you could hold two atoms that are bonded together, twist them, and not change bond length. Would it be easier to twist or rotate around a single bond or a double bond? So this is actually a pretty standard question. So let's say we're comparing two different molecules. We're comparing this with this. So remember when we compare our single bonds to our double bonds? A single bond is weaker than a double bond. The interaction between those two carbon atoms is weaker when we have a single bond versus if we have a double bond. So based on that, we know that the bonding on the right is going to be stronger than the bonding on the left. And because of that, it's easier to rotate a single bond than it is to rotate a double bond. It's just easier to manipulate the electrons holding a weak bond together than it is a strong bond together. Like, think about it this way: it's a lot easier to twist like a thin piece of string around than it is to twist a thick piece of rope. It's the same basic concept. In fact, this has very interesting properties because as you'll learn in organic chemistry about the chemistry of alkenes, and those would be carbons with a double bond.